Okay, today we will talk about 7.2 and 7.3. 7.2 is about estimating the population mean, and 7.3 is estimating the population standard deviation or variance. Okay, so starting from 7.2, so some review of the notation. This symbol is mu. It represents population mean, and X bar is the sample mean. This is sigma, which is the population standard deviation, and S represent the sample standard deviation. We will use these letters later. Just a quick recall. Okay, so in section 6.3, we talk about mean is an unbiased estimator. So there are three unbiased estimators we talk about in 6.3. One is proportion, one is mean, and one is variance. Those three are unbiased estimators. That means the sample mean will target the population mean, right? The mean of the sample mean is equal to the population mean. Okay, so that means we can use the mean of a sample to estimate the mean of the population. Okay, and then we will, the sample mean is the best point estimate, right? And to find the confidence interval, if you want a little range to estimate the population mean, this is the formula. It's the sample mean minus margin of error to sample mean plus margin of error. While based on different situations, margin of error is found differently. So two cases. One case is sigma is unknown. So recall that sigma is the population standard deviation. So when population standard deviation is unknown, then we use this formula to estimate E, and when population standard deviation is known, we use this one. But this is usually not happening because you're trying to know the population mean, right? That means you don't know the population mean, but somehow you know the population standard deviation. This is calculated by using the population mean. So usually this won't happen. This case is really, really rare and realistic. So usually we're talking about this case when we don't know the population standard deviation and we're trying to estimate the population mean. Okay. And here, t distribution. If you don't know the sigma, you will, instead of z, you would use t distribution. T distribution is pretty similar to z. It's pretty similar to standard normal distribution. The mean is the same. Number in the middle is 0, but the standard deviation is changed. Standard deviation is s divided by square root of n. So standard deviation is changed based on your n. Okay. Anyway. But we usually don't use the formula because you can just use technology to find the value if you know where to find it. Let's look at one example actually from our homework. So let's see. Which one would that be? Okay, so can you see the homework?
Yeah.
Okay.
Yes.
So This is all like definition, definition, definition. Okay. Take this one, for example. A trial was conducted to test the effectiveness of a drug for treating this disease. And before treatment, 21 subjects has a mean of wake time of this many minutes after treatment. Okay, so this is before. This number is confusing. Okay, I want to write on. Okay, there we go. All right. So after the treatment, 21 subjects. So N is 21, and this sample has a mean. So X bar is 82.9. And that sample standard deviation, which is S, is 24.9. And here they satisfy the requirement. It's normally distributed. And we want to construct a 90% confidence interval. Okay. All right. All right. So here we will use, since the population standard deviation sigma is unknown and we're looking for the population mean, we use T distribution instead of Z distribution. Okay, so where do we go on StatCrunch? You go to StatCrunch and stat the T-stat, because you're trying to look for the population mean and sigma is unknown. That's T-stats. One sample, in our case, is with summary because we know all the values. So what do we know? We know your sample size is 21. That's your N. Sample mean 82.9. And this is sample standard deviation 24.9. All right, here you choose confidence interval, confidence level 0.9, and then just compute. He will give you the interval, lower limit and upper limit. So go back to the problem. So 70, I'll write it down over here. So 73.529 to 92.271. So then put it in our answer. Where's the problem? There it is. So it's between, round to one decimal place. So that's 73.5 to 92.2. All right, then you compare this with the before treatment, which is 104. And this is not even in that interval. So that means it's kind of, it's effective, right? So does not include this. This means the mean before and after the treatment are different. They're definitely different because 104 is not included in that interval. So suggests that it has a significant effect. Questions on this problem?
Nope, I don't have any.
Any other questions on the part? Okay, let's talk about this one. This one, instead of giving you the summary, they give you a set of data, right? So using the set of data, you want to find everything. So it's pretty similar to the previous one. So open your StatCrunch So here what do we know? We know we have a sample and we want to construct a 98% confidence interval to estimate the mean, the population mean. Okay, so we open this set of data in StatCrunch. So we have all the sample values here. Since we don't know the population standard deviation, we don't know sigma. So that means it's t-stats, one sample. Here is with data instead of with summary. With data, and choose the column. Now, and confidence interval, which is 0.98. Okay. 0.98. Compute. You have the lower limit, upper limit. So probably round to 3 decimal places. So that's 0.253. The other one is 1.112. Okay. There you go. And you compare this with 1. And does it appear that there's too much mercury? So this is the standard, right? It should be below 1. And it's this one, but 1 is included in this interval. So is it too much mercury? It's hard to decide. So let's see. No, because it's not possible that the mean is greater than 1. I didn't know it's possible. Yes, because it is possible. Okay. No, because it is possible. Is not greater than. Also, at least one of the sample exists so that at least some of the fish. Oh, wow. I think I will go with this. Yes, it's too much because it is possible that the mean is greater than 1. Also, at least one of the sample exists this much. So at least one of them. Okay, I'll pick this one. All right. All right. Anything else on 7.2 you want me to go over?
Nope.
Okay. 7.3.
Oh gosh, yes.
I just figured it out like 2 minutes before this meeting. I can't believe it.
You just did number, what number was
10,
it?
and it was 10, and then it was the that chi-square, the 3 questions. I
Yes.
just figured it out.
That one I have been stuck on for 3 days now.
Me too. Me too. And I just figured it out. I cannot believe it.
All right. Why don't we look at 7.3? All right. So 7.3 is to estimate the population standard deviation or variance. So here we use, this is called chi-square distribution. I know it says CHI, but you know, from what I know, chi-square is the most popular pronunciation. Chi-square.
Yeah, I want to call it chi, but it is. Yeah.
Chi-square distribution.
Chi.
Yeah, it's chi. I don't know why they use this, but they actually, anyway, chi-square distribution. So you can tell it's not a symmetric distribution. It's skewed to the right, and you use degree of freedom. So this is depend on n, this curve. You can tell this is the curve when n is 11. This is when n is 21. All the values are positive. So something we need to know about chi-square distribution. All right. Some requirements. The sample needs to be a simple random sample, and the population must be normally distributed. So this is kind of like a strict requirement. Well, let's just look at one. That's pretty much everything we need to know about estimate. a population variance or standard deviation. So which one is starting?
10.
10. Okay, let's look at number 10. 10 it is. All right. Oh, 10 is the easier one. Okay, let's talk about 10. 10 is kind of easy.
That's the easy one?
Yeah, that's the one that you had to figure out how they got those.
10, everything is given to you. You know the sample mean.
Even inputting the information in, I still couldn't
No,
change it.
I couldn't figure out how they got that
Let's see.
table or the number. I finally did, but I mean, I couldn't get those.
Well, this one is when you want to do it by hand. And
yeah,
you
don't
need
do it by hand.
Oh, no.
If you want to do it by hand, you need to use this table to find the corresponding value. For example,
I couldn't even find it by
your
doing that.
N is 104, right? So
Yeah, but it doesn't go to 104.
It doesn't go to 104.
It goes to 100.
Yeah, I know. So you probably go to use the one for 100. That will be close enough, I assume. Higher than that is right here. Anything high? Oh, no, it's not. Anyway.
Oh,
it's
okay,
beyond the table. It's beyond the table. Let's not use this. Let's use technology. Let's go to StatCrunch.
I cannot believe you will flip out when you figure out this. I could not believe it.
I've been on it for 2 days now.
I know. You put the percent, that 001, and you put the, your N up there, then you compute it. Then that gives you that number.
So let's see. It's variance stats, one sample, and this one is with summary. Okay, samples variance. Sample variance is, you may think it's S, but that's sample standard deviation. Sample variance is S squared.
Yes.
So instead of, okay, so S is 0.63. S squared is 0.63 squared. I think they do calculation here.
Yeah, if you do 6.63 to the power of...
Yeah, then that'll give it to you.
Yeah, so I would do it like that. And sample size is 104 for this problem, 104. And then what else do I need? Confidence interval right here. It's 0. My problem is 95. Okay, good. Compute. It's right here. You have the lower limit, upper limit, but this is the limit for the variance of population variance. What you are asked to find is the population standard deviation. So what you need to do is take square root of these two values and put it here.
Oh, I use the I'm going to say it wrong. I use
the chi
calculator.
Calculator. You can use that. But that will give you the chi-square, and you have to plug it into the formula.
Correct. Yeah, you have to plug into the formula, but that's what I did. But that's how I could never figure out those numbers.
So you have this, and I'm going to put it in a calculator, which is, where's the calculator? Yeah. I'm just going to go copy.
That really is simple.
Yes. Copy, and let me paste it. Can I paste? Yes, I can paste. And I want to take square root of this number. It's they want to round it to 2 decimal places, so that's 0.55. So 0.55. For the other one, the upper limit is this number, but that's sigma squared. So for sigma, you need to put this here, paste, and then take square root of that. It's 0.73. Okay. All right.
Oh, goodness gracious.
Yeah, I did it with the calculator, and I had to figure out the square thing, but I couldn't believe that either. I was just like, this is probably simpler, but I know how to do it the other way. So
Well, there's two other questions that ask you pretty much to do the same thing.
Mm-hmm.
Yes.
And I even tried it, but I think I must have entered the wrong information in.
So this one is a little bit different. This one's giving you the data. So you pretty much go through a similar process, except let me erase everything here. So you go to variance stat, one sample, but with data. And then choose the column. And then over here, just pretty much here, 99% confidence level. So 0.99, 99. And then just compute. But what you're given is the variance.
Mm-hmm.
You want to find standard deviation.
So you have to square the
square
lower
root.
and the upper.
Square root them. So
Yeah,
take
square root
this.
them.
So, well, clear this. Paste this and square root. That's the lower. So 246.1 decimal place. So 246.7.
So much easier than even what I figured out.
246.7. And the other one is this one. Just copy and calculator. Paste and square root. So 791.1.
Yep.
791.1 and check. There you go. Okay, done.
Oh my gosh. That's just crazy.
All right. Do you have any other questions?
I don't.
No, I was stuck on that for, like you said, 3 days.
I know. I was like, man, I'm going to get a jump on this week. I'm good to go.
Me too, because I'm like flying out tomorrow and I'm like, I'm going to get my quiz done. I'm going to do it. And I was like, oh, okay. Not.
Guess not.
Well, now you could.
Yeah, now I'm going to, now that I know how to do it.
All right. So
All
if
right.
you don't have any questions, let's call it a week.
Sounds good. Thanks for the
Thank
help,
you.
because that was actually pretty easy.
Yeah.
All right.
Oh my
Bye.
Bye.
God. Bye.